Okay, ladies and gentlemen, this is week 2, day 1. Wonder if we can get my face up here. Bring up an image so you guys can see. Well, I want to look at photos. And turn it around. Nice. Okay. So, hope everybody's doing okay. Just thought maybe I just, make it look a little more familiar, or at least in case some of you guys, maybe it's been so long you forgot what I look like. So, anyway, yes, that is my Christmas tree. Okay? We leave it up all year. What we do is we kind of decorate it throughout the year based off of what month that you're in. Fortunately, March is kind of, there's not really a whole lot in March. And so as you can see, it hasn't been decorated since February, since Valentine's Day. So anyway, if you guys got any great ideas to, decorate the tree for the month of April, feel free to drop one by. Obviously, Easter eggs would be a good one. Also, if you guys didn't happen to know it, today is my birthday, so maybe put some birthday presents up there, Anyway, just being silly. So, anyway, I hope everybody's doing okay. The point of me of just showing my face here, I feel like, all these videos, I'm just sitting here doing a lot of talking, and you don't really know who's talking to you, or at least maybe in some of you guys' case, you, like I said, might have forgot what I look like. So anyway, I just wanted to address, just want to say hi. So anyway, I need to address anything. Really no issues. If you have any questions though, feel free to contact me at any point, you guys. All right. Any questions with, finding materials? If you need help on a particular problem, I can send you a video, and then I can share the link so you can watch me solving a math problem in real time. So any questions, guys? We're all pretty well new to this. All of us, adults and students alike. So it's important that you guys are communicating and making sure you're letting us know what works and what doesn't. So anyway, I know there's also a lag in this too. It's unfortunate. So my mouth probably isn't matching up with what I'm saying. But regardless. So anyway, let's get back to the problems here. So we're talking about parallel and perpendicular lines. Okay? Now, in this, we're going to be talking a little bit about slopes as well. Okay, slopes play an important part when you're talking about lines, because remember, y equals mx plus b. All right, this is the slope-intercept form for linear equations. Okay, and a key word in linear is line. Right, so when we're talking about lines, we end up kind of talking about slope, right? Not so much intercepts, okay? But we might talk about intercepts in this section, regardless, right? So when we're talking about parallel and perpendicular lines in reference to slopes, okay? What we got to remember is when two lines are parallel, okay, that's what that symbol means, parallel. Right? That means that their slopes, and actually, I'll put it like this. I think I've seen it represented like this. Right? That way people know that we're talking about not the number 11. Slopes are equal, okay, or the same, right? When two lines are parallel, it means their slopes are equal. When two lines are perpendicular, it means their slopes are negative reciprocals, okay? Which means, let's say, for example, we have a line that has a slope of 1/2, okay? If we wanted to come up with a line that's perpendicular to this one, the slope we would need, okay, would have to be the reciprocal. So the reciprocal of 1/2 is 2/1, and it would also have to be negated, okay? So whatever line we come up with, all right, the slope needs to be negative. negative 2 over 1. So that's what I mean by, negative reciprocals. Okay. Now, a lot of this stuff kind of stems from Algebra 1 as well, all right? So if you've forgotten about how to find the equation of a line, all right, there's a few ways you can find that. So you got y equals mx plus b, which is your slope-intercept form, right? And then there's the point-slope formula, which is y minus y1 is equal to m x minus x1, where x1 and y1 is just some point. Okay? Now, in this case, okay, we're given the equation of a line, and we want an equation of a line that's going to be perpendicular to this line right here, and we want it to include this point. Okay, so that's what it means by passing through. Whatever line we come up with, it must also have the solution of 6 comma negative 4 in its table of values. Okay? So let's first take a look at this equation right here. So it's negative 1/2 x minus 5. So if we want the equation of a line that's going to be perpendicular to this particular line here, right, we need to look at its slope. And its slope in this case is negative 1/2. Right? So what we need, all right, is the negative reciprocal of a negative 1/2. All right, so first we're just going to flip the fraction, and then we're going to negate it. So in this case, you would have a negative number, right? And two negatives equal positive. So basically it goes from negative to positive. So what we need is a slope of 2. Okay, that's what we need. All right, so actually let me just resolve that. Let me just put it right in here. What we need is a slope of 2. Okay. So that's what we need. And now, in order to finally finish this problem up, okay, in order to find the this equation, we must take this slope and take this point and plug it into this equation right here. So this is how you do it. Okay, so we're going to go y minus negative 4 is equal to 2, which, don't forget, m is just equal to your slope. Okay, so in this case, m is still stands for slope. So it's going to be 2 times x minus 6. And you want to distribute the 2. Alright, and so you end up with, well, not a room here, y plus 4, because we've got a negative and a negative, equal a positive, is equal to 2x minus 12. Subtract 4 from both sides. You're left with an answer. Let me put it in nice blue colors here. Y is equal to 2x minus 16. And do we see that answer? We sure do. Okay? So now we found the equation of a line perpendicular to this particular line and then passes through this point. Okay, that's number 1. Number 2. In the diagram below, FE bisects AC at B, and GE bisects BD at C. So which statement is always true based off of this information right here? All right, so this is almost kind of like a conclusions problem as well. All right. I guess it might not technically fit in this unit, but we've done this before, and so it's important we do every Regents problem we can anyway. So that being said, all right, this is what we're going to look at first. So we see FE bisects AC at B. So when it says bisects, what that means, the word bisects, is it cuts it in half. So FE bisects AC at B. at this point right there. Oops, let me get in the color you can see. That color right there. So which means these two lengths are the same. And then the next one says GE bisects the line segment BD at C. Now we have to be careful when we read these, okay? What it's saying is this line, GE, all right, cuts this line segment in half. All right, so that means that CD is also equal to BC, right? Because if BC is this length, well then that means CD is also that length as well, right? Because it cut that in half. So actually what we have is we have 3 equal lengths. All right, this line right here cuts this line in half, making 2 equal parts. And this line cuts BD in half, creating 2 equal parts. Okay, so what happens is you end up getting 3 equal sections here. Okay, so that being said, let's read what it asks. It says, which statement is always true? So it says AB is congruent to DC. Now, I would suspect this is probably our answer. All right, because this is always true, because this is, we didn't have to like prove that this is just comes right from our given. All right, then it says FB is equal to EB. Okay, we got to be careful about this one. Okay, because you know line segment AC does not bisect FE. All right, it's the other way around. FE bisects AC, which means FE cuts the line segment AC in half. So that one's false. BD bisects GE at C. Well, no, can't assume that. All right, because it's the other way around. GE bisects BD at C, not the other way around. And then AC bisects FE at B. Nope, because that's just switching it back around. Okay, this isn't one of those properties where it goes both ways. All right, it would have to say both. It would have to say FE bisects AC and AC bisects FE. Okay, so the only one that's true would have to be number 1, right? Just based off of what our givens tell us. Okay. Let's take a look at number 3. So which equation, right, represents the line that passes through the point -2, 2 and is parallel to this line right here? So this is a key word this time, parallel, which means, all right, whatever line we come up with, we're going to take that slope. All right, so the slope of this line is 1/2. So what we need is, again, a slope of 1/2. Right? Because in order for these two lines to be parallel, whatever equation we come up with, it must have the same slope, which in this case is is positive 1/2. And now, finishing off, it needs to go through this point. So again, we got to use our equation. Y minus y1 is equal to m x minus x1. Okay, in this case, x1, and y1 is just -2, 2. And our m is equal to 1/2. So then we just plug it into this equation here. So let me move it over. So it's going to be y minus 2 is equal to 1/2 x plus 2. Okay, you're going to have 2 negatives in a row there. -2 equals positive 2. You distribute that 1/2. And you end up with y minus 2 is equal to 1/2 x plus 1 add 2 to both sides, you get y is equal to 1/2 x plus 3. And please tell me it's up there. Yes, it is. Excuse me. All of a sudden, I'm just going a little bit hoarse here. Pardon me. All right, but yes, we do see that answer up there. Y is equal to 1/2 x plus 3. So good. I'm happy. Excuse me. Yeah, my throat just went dry there. Okay. Yeah, let me get a drink of water here. Hold on a second there, folks. Crikey. All right. So, what is the equation of a line which passes through 6, 9 and is perpendicular? Okay. Perpendicular to the line whose equation is 4x minus 6y equals 15. Now, we haven't talked about this form yet. This is still a linear equation, but we call this form standard form. Okay? And so, standard form, unfortunately, doesn't really give us our slope or what our y-intercept is. Okay? Now, we don't really concern with the y-intercept, but when we get it into slope-intercept form, we're more concerned with what the slope is, because once we find our slope, then we can determine what slope we need in order to come up with an equation that's perpendicular to this particular line here. All right, so first thing we want to do is we must get this into slope-intercept form. Okay, so slope-intercept form. Whoops. Again, looks like this. Y equals mx plus b, which means we are trying to get y by itself. So our first thing we're going to do is we're going to subtract 4x. We get negative 6y is equal to negative 4x plus 15. Divide by negative 6. We get y is equal to, so negative 4x divided by negative 6 would give me a positive 2/3 x. And 6 doesn't really go into 15. Okay. But we can certainly, well, actually, do I need to make, yeah, my bad. I'm sorry. So this is going to be, because we're not concerned with our y-intercept, I'm sorry. Had a moment. So 15 over 6, we can simplify that by a factor of 3. So this is 5 over 2. Okay, you divide 3 into both of those pieces. So what is the equation of a line that passes through 6, 9 and is perpendicular to the line whose equation is this? Okay, we take a look at what this line is. So this line is in slope-intercept form, and to come up with a line that's perpendicular to this one, we need to look at our slope here. So our slope is 2/3. So what we need, okay, is a slope of negative 3 over 2. Okay? So that's what we need. So we need a slope of negative 3 over 2, which means we can cancel these two out. Now, if you're wondering what form this is, how they got these equations written, this is point slope form. Okay? So which means all we have to do is find which one has the point entered correctly into this equation. So, if you remember, the equation goes y minus y1 is equal to m times x minus x1. Okay? That's what our formula looks like. So, when we look up here, okay, we notice we have a positive 6 and a positive 9, which means when we plug it in, both of them should have a negative sign in the front. So our answer is number 1. All right, let's scroll down to number 5. So write an equation of a line that is parallel to the line whose equation is 3y plus 7 is equal to 2x and passes through the point 2 comma 6. All right. So, easy enough. Parallel. All right, so which means we need the same slope. So take a look at this problem here. Right? What do we see? We notice that it doesn't have y by itself. Right? We want this in y equals mx plus b form, which means we're going to have to get y by itself. So I'm going to subtract 7 from both sides. So you get 3y is equal to 2x minus 7. Divide by 3. Make sure you divide both pieces by 3. Okay, so you're going to get a 2/3 x minus 7/3. And now we're not so concerned about the y-intercept. What we're concerned about here, again, is our slope. So what we need, okay, is the same slope, which means we need a slope of 2/3. So, now, it says write an equation. Okay, it doesn't say which form we could use. Now, if you want to, we could always put this in slope-intercept form. Or we could just leave it in, point slope form, right? Okay, because it's not specific, it doesn't tell us which form. Now, I mean, if you want to convert it into standard form, you can, but I would suggest not, okay? So we're going to put it into this form right here, minus y1 is equal to m times x minus x1. In this case, x1 and y1 is equal to 2 comma 6. So we just plug that in with our slope. So y minus 6 is equal to 2/3 x minus 2. And that is it. Shrink that down just a tad here. Okay, so those are the answers to day 1. All right, so hopefully you guys are following along. Hopefully you guys find this useful. And make sure you guys are keeping up with these, okay? Please.